welcome to everyone. Thanks for joining us today. My name is Julia. I am structural engineer at CREE and the moderator of today. This is our second CREE talk. Just very briefly, for those of you who do not know CREE, CREE is a global construction collective delivering systemized timber hybrid buildings in local markets. We are orchestrating in Europe, Asia, and since this year, also in the United States. As part of our 10th year anniversary, this CREE talk is dedicated to the topic of digitalization of the planning and construction process. Together with selected industry experts, we will discuss the current planning and construction process. What are the challenges when it comes to digitalization? What are solutions which are already in place? And what could the future look like for the topic digitalization in the construction industry? Now, if you think about it, digitalization gives us much more transparency, like a digital twin, seeing all the processes, having access to more information. It gives companies and people the opportunity to share information. When you compare digitization and digitalization, digitization is a conversion of data and processes, whilst digitalization is a transformation. More than just making existing data digital, digitalization embraces the ability of digital technology to collect data, establish trends, and make better business decisions. So today we want to take a close look at how digitalization is already implemented in the planning and construction process. I would like to welcome all the guests that have registered today. And I also want to, of course, welcome our speakers today, the participants in the panel. And for this, I would like to say hello to Nick Milestone. Let me just briefly tell you a little bit about Nick. Nick, you are a veteran of the European and United Kingdom mass timber markets and the current chairman of the Timber Research and Development Trade Association. You recently joined the Softwood Lumber Board to support its mission in the areas of strategic partnerships and adoption of mass timber construction in the United States. Previously, you were the director of mass timber at Catera, the director of offsite manufacturing at the William Hare Group, and the managing director of B&K Structures, the largest mass timber construction business in the UK. Hello, Nick.
Hi, how are we doing?
Thanks. Good. It is a real pleasure to have you and that you're taking part in this. Now I'd like to bring up our next guest today, which is Patrick Streamla. I would like to introduce Patrick just briefly. Patrick, you're an architect with special interest in sustainable and socially integrated buildings and cities. Since 2016, you have been managing partner of all Dietrich Untertrifaller locations, together with Helmut Dietrich, Much Untertrifaller, and Dominik Philipp. During your studies at the University of Karlsruhe in Germany, you worked for several renowned architects like Massimiliano Fuxas, Paris, and as of 2002, regularly with Helmut Dietrich and Much Untertrifaller. After graduating, you started at Benisch Architekten as project manager and became project partner in 2012. You are a member of the Chamber of Architects of Bavaria, as well as of Tyrol in Vorarlberg in Austria. You regularly give lectures and at renowned international events. Patrick, it is a pleasure to have you here.
Thank you. Hello, everybody.
Okay, thank you, Patrick. Then I would like to introduce our third panelist, Sebastian Fischbeck. Sebastian, if I may introduce you just a little bit. Currently, you live in Berlin in Germany and work on multiple timber buildings for both residential and commercial clients. Your bioclimatic approach to architecture focuses on user wellness, operational efficiency, and the exploration of passive sustainable strategies that integrate building orientation, material selection, and experiential factors. Previously, you taught at Duke University as instructor for architectural design at the Trinity College of Arts and Sciences, and you worked as lead design architect in multiple offices throughout North America. You have overseen large projects and master plans in a variety of countries, including Italy, Austria, Germany, South Africa, Canada, and in the US. Hello, Sebastian, and good to have you here.
Hello, everybody. Thanks for having me.
Okay, now I would like to introduce our next guest, which is Bernhard Gaffner. Let me briefly tell you a little bit about Bernhard. Bernhard, you're an absolute leader in mass timber engineering and on the forefront of introducing these products to the global markets. You're currently principal at Aspect Engineers, and you also sit on various engineering and non-engineering committees. Your current projects span from Israel, Switzerland, Portugal, USA, and Canada, all the way to Australia. You are also heavily involved in the development, design, and implementation of mass timber and mass timber hybrid building systems, such as the Sidewalk Labs and CREE systems. Welcome, Bernhard.
Thank you.
Now, I would like to say hello to my colleague, Wojciech Nitzwitz. Wojciech, if I may introduce you a little bit, you're an experienced MEP engineer specializing in HVAC systems and thermal modeling simulations. Prior to joining CREE buildings in 2019, you spent over 20 years working with several MEP contractors in the UK. At CREE, you coordinate all activities between CREE headquarters and the North American partners. Furthermore, you have also the lead for the digital content on the CREE platform. It's a pleasure to have you in the discussion. Hi.
Thank you.
Okay, now I would like to introduce our sixth panelist, Markus Golinski. Let me also briefly tell you a little bit more about Markus. Markus, you're an experienced timber engineer and manager in the field of timber construction. After having worked as a carpenter in the late 1990s, you studied timber engineering in Hildesheim in Germany and Kotka in Finland, followed by working in various positions in the timber construction industry, ranging from design engineering, structural engineering to project management. Between 2011 and 2015, you finished your MBA at the University of Applied Sciences, Ludwigshafen in Germany. After joining German timber construction company Hess Timber in 2010, you held from 2014 onwards the role of sales director and have been a member of the executive board before becoming managing director in 2017. During the time at Hess Timber, you were involved in carrying out several international timber landmark projects, such as the first commercial wooden multi-story office building in Sydney, in Australia, or the waste to energy plant in Leeds in UK. Hello, and also good to have you here.
Thank you for the invitation.
And last but not least, I would like to introduce our seventh panelist, Rana Straugh. Rana, also, if I may introduce you a little bit. You are an experienced construction engineer, certified passive house designer, and accredited sustainable building auditor. You worked with several companies in planning and construction management before you joined the Lifecycle Tower Research and Development Team, which was later established as CREE Buildings. At CREE, you have developed the LCT timber hybrid system, which then became the basis for CREE's prototype building, the LCT1, where you're currently sitting, and many more buildings. So being the CTO of CREE, you head or lead our technical operations, international know-how transfer, and licensed partner consulting support. Just recently, you became CREE's managing director. Welcome, Rana.
Thank you, Julia.
Okay, so we're quite a big round today, and I'm really looking forward to hearing all the various perspectives with regards to our topic. So thank you all for being here. Now, before we move forward in our agenda, I wanted to mention that this session is being recorded and will be made available afterwards to all of you who have registered. Okay, before we go into the questions and debate here today, I would like to open up the floor to Rana to express his ideas and thoughts on today's topic. Yeah, Rana, I hand over to you.
Thank you so much again for all the introductions. I mean, I would like to make it short because I'm really interested in the questions and in the discussion that is going to unfold then. The reason why we're here, because we got to know each other along the way that CREE has taken in the past 10 years. And this is also one reason for this session here. It's one part of our 10th anniversary celebratory sessions that we do on different topics. And I'm especially pleased to have you guys all here and Julia as well, because we kind of happened to meet during those years. And it's if I look at you all, it's almost like the journey starting with Bernard in 2012. I got to know him when he visited the almost completed LCD1. Then we happened to reconnect in Vancouver, where we also undertook some experiences or some endeavors. And back then, we still believed that we need to plan and design and build everything by ourselves. But later on, we realized that the demand is just too big, that we can do all that stuff with CREE ourselves. And we also realized that our construction system lends itself perfectly to everything that can be put into the digital world. And Julia, you gave this great explanation between the two, digitizing and digitalizing. I'm not sure if if everyone sees it like that, but I mean, you probably know that saying that a crappy process remains a crappy process no matter if it's digitized or not, right? So that's why we needed to change the processes. And digitalization helps us with that. And digitalization also helps us create this worldwide network that we now working on, and also helps us maintaining that network. Yeah, that's why we are here. I mean, I would like to tell you later about some interesting digital things that go on because of the sad situation we are in health-wise, that also brought a lot of things forward. And let's talk about that a bit. And then I already mentioned that collaboration is key. That's what we believe in, and digital tools just help us perfectly by doing so. So let's open the question and discussion.
Excellent.
Thank you again for joining us.
Thank you, Rana, for setting a little bit the stage of today's discussion. I want to begin with a question to all of you, and I'm going to start with Wojciech. Wojciech, what does digitalization mean to you? What is digitalization for you, just in general?
It's such a big subject, isn't it? For a starter, it enables us functioning in the modern world. It would be difficult to imagine to perform our daily routines, daily tasks without various digital tools. But as you said, and Rana has mentioned, it's not just about the digital tools. It's all about the processes of integration, automation, and structure, which make our work more efficient and more effective. So digitalization to me is more about enabling, transforming, and improving our business operations. And in particular, when we talk about the building construction industry, it's the building information modeling, the BIM, that is exactly what the digitalization is all about. It's a process of digital transformation of the building industry.
Thank you. Maybe Bernhard, same question to you. What does digitalization mean to you? What is digitalization for you?
I would look at it through the lens of, from the structural engineer and answer it that way. Like for us, it is a way of integrating, collaborating better with the other design members or members of the design team, as well as everybody else down the supply chain, right? So it's not just about the design, it's also about what happens after. Like somebody needs to produce and to build it, and that's where, for example, Marcus and his team come into play. And so having an understanding of those, those interfaces, those processes, where we can really start to streamline and do things better. The one challenge that we see often goes back to what Rainer said about the process, right? If the process isn't in place, like it doesn't matter. Like you still need to open up that human connection and have somebody on the other side understanding what you're doing and where you want to go, and then collaborate with them. And there's a lot of, as also mentioned, happened in the last year where we were all forced to collaborate online, digital, and that was, a good thing in our mind. And so there's going to be a lot of progress made in the next few years, even like after this. And so it's just the start of a journey, I'd say for now. And it just takes, I think, building systems like the CREE system, where you can have a better integrated and smaller supply chain from the design all the way to the end, that can really spearhead that implementation of that in the built environment. Because a lot of projects that do not lend themselves nicely to it. And a lot of project teams, like, you want people focusing on the outcome. And right now, there are a lot of folks that are more working on the software and solving or wrestling with the software versus working on the process. And so there's also a fear of that you have all those tools and you're spending all that time, but the end result isn't much better, right? And so there's still a lot of work that needs to be done, and also being honest with ourselves on what we can achieve with whom at what time.
Yeah, very good points. Thank you. Patrick, what does digitalization mean to you? What is digitalization for you?
Digitalization for us means a bit of better life, actually. I mean, we as architects, when you look at the process chain of building, we are kind of in the middle and kind of the motor. We push the development of the project. We invent the project together with the others. And what we were doing over the last in the last years was more or less only carrying information from left to right, taking Bernard's structural engineering information, putting it here, and taking other information, and then after the process was over, we carried this information to the companies. And today, over the digitalization, we can work much more integrated, and we can concentrate on what is really important. And this is like this idea of this digital twin and loading every information that we have in this one model. And so do the others. And so we are, we can enter into what we call this integrated process much better than we could as we were still drawing these 2D plans and sending them by fax or by post or later by email. That was not really digitalization in these days. I mean, digitalization starts in construction, absolutely starts with BIM.
I hoped for hearing some of those things, like using fax. And that brings me to my next question. Do you remember your first encounter or your first touches with digitalization in construction? And please, Nick, if you could answer the question.
Absolutely. My first experience with digitalization was in 1996. And I was working for a structural steel company, and we never thought that structural steel was actually the first off-site technology of DFMA. We just never labeled it as that. It was just a new technique that was competing with concrete. And then the days of BOCAD and X-Steel. And the reason why we went down the digitalization route is for accuracy, for producing the what we call the CAMEX files, the CNC data for offsite cutting and drilling. Well, that technology became a huge realization where it went everywhere, vertically integrated within the supply chain. And what I mean by that, we could start creating 3D models at bid stage. We then use the 3D model to effectively do all the manufacturing. And now we use the 3D model for the installation. And then when we went into the world of BIM, which was around 2008-9, which was pretty much the start of the financial crisis, it actually took a big step backwards, because in order to accept digitalization in any organization, it's a behavioral change and culture change in the processes. And of course, when the financial crisis came, a lot of the general contractors were cutting back on staff, and the general contractors were the actual key to opening this up, because the supply chain operates in a 3D environment. In order to make VDC or the digital twin be effective, it has to have ownership from the stakeholder right down the entire supply chain and working in a federated environment. Now that significantly reduces the time to process a building to site. So if we go back to first principles of get it right first time, the Japanese culture before BIM was about spending 2 years on a building project with the entire supply chain pre-bought into it and creating a get it right first time to avoid clash detection, to avoid errors, and to improve the process. We're in a world of BIM now, which we're now bringing in the world of AR, VR, and of course, we're in the world of algorithms. So we're accelerating at such a great pace. But the supply chain has got its house in order. It's everything above the supply chain that has to change its behavior. That's the key to unlocking true VDC. And I can give you a good example of that. So I am and still heavily involved in the Nanyang Technical University in Singapore, which is the world's largest mass timber building at 15,000 cube. And from the very start of the journey, we're doing AR. We can walk the job with a headset on. We know how it's going to look. The sad fact is, and whilst Singapore's got a great aspiration to be advanced in the field of VDC, it fails massively because it's a behavioral change and a cultural change in a construction environment that still very much works in 2D environments. And, you know, without being disrespectful of my Singapore colleagues, they very much see BIM as a set of 2D drawings and a marked up pen, taking a photograph and sending it on WhatsApp. That's their idea of BIM. That's bad BIM. Yeah, that's lazy BIM. BIM is about being in an environment where the whole supply chain, not the supply chain, the stakeholder downward has to enforce BIM to make it effective. In my entire career, I've only ever done one mass timber project in a federated environment, and we reduced the lead time down from 14 weeks to 9 weeks because the architect was sending back the BIM model with the clash detection report. We just saved a whole load of time with RFIs, TQs, you name it. It's the future. And guess what? Using BIM at bid stages, not just as a pretty rendered model, but actually using the technology at BIM stage gives such accuracy on 4D and 5D BIM, which is cost and program certainty. And the technology is moving there, but I think it will take at least 10 to 20 years before the entire construction industry truly embraces it. It's a cultural change. It's a generation change. I see a few smiling faces. There's a few nodding faces as well. Yeah. The grey hairs count for something.
It's very interesting what you're saying, because we are now at the moment, quite a few of us at CREE undertaking a BIM management course, and it's very interesting to see how BIM implementation and adoption is different in different countries. But it's quite obvious that the world is now rapidly following BIM.
It has to.
It has to, yeah, indeed, and in order to make our life easier and more effective, we have to follow that. And it may be, I don't know, responsibility a little bit on the government side as well, that they have to push that agenda forward and make some projects, like in the UK, for example, where some projects, governmental projects, have to be done within BIM environments. Maybe other countries have to follow the same idea.
UK government mandated BIM as its publicly available specification. The only way we're truly going to get BIM, I work with companies who are BIM level 2 certified. That's just a little bit just above lonely BIM. What we need is to have an ISO for BIM. That's what we need. We need an international standard for BIM. And that would then force a lot of companies down a track, definitely.
Which is interesting what you're saying, because we've been doing that course using still PAS, which even our tutor is saying that he knows that PAS is now being replaced with ISO standards, but we're still learning that in PAS. So
yeah, absolutely. Yeah,
it's not ideal yet.
That brings me back to collaboration, and I tell you why. Because Nick, you're calling for the government to kind of unify BIM standards. But if you then think about public tendering procedures, where somebody sits in somewhere and develops a building and then throws it on the market, and you can't do anything about it anymore. No. This is not what we want, because digitalization and 3D modeling and creating the digital twin requires early involvement of the stakeholders. And how do you do this if you're not allowed to? Yeah? So if you want to do that, then public tenderers, they will just not allow you to do so, because they are forced to avoid that somebody gets involved too early, because that restricts the free market. And this is also a task for the government, I believe.
Well, I think you're absolutely right. And cost is king, unfortunately. And, general contractors have some very, very bad habits. Doesn't matter what country you're in. And their business model is they don't have an integrated supply chain. They're a management contractor and they outsource the risk. And their business model is to sell high and buy low. That's how they achieve their profits and live off the cash flow of the supply chain. That's not uncommon across every country. You're right, that completely removes the aspect of collaboration. You need your supply chain integrated at the very, very start. And what I am starting to see in the UK market is a change in culture, where we're now having PCSAs agreements, pre-construction services agreements, where effectively it's half a step toward a marriage with a specialist subcontractor who can offer that service as the integrated VDC provider within the federated environments. But by the time the design is complete, then they are market tested. So it doesn't remove the contractor's game playing or trying to get the price down, because that's where we are. That is probably the biggest prohibitive factor of why VDC is not as advanced as what it should be in the construction sector, because people are too much focused on cost. And so I think that I think is the biggest prohibitor. And people are scared of new technologies. And when I call by new technologies, everybody's familiar with steel and concrete. You start bringing mass timber into the equation, well, there's not enough knowledge on the planet. Whether that's a design engineer, a draftsman, suppliers, installers, there's not enough knowledge on the planet. The often reason why we see mass timber being adopted is because of the stakeholder wants it and will not be deterred from that. But one thing I know that will be of benefit to everybody on this call and the attendees is the fact that sustainability and climate change has got a real reaction now. And I believe now is the time for mass engineered timber to either be the solution or a part of the solution agnostically with other materials. And it can't be ignored, because mass timber is the low hanging fruit of climate change. That's got to be the right way forward. And I can start seeing that. And I think a lot of people who know me personally is I'm very passionate about hybrid. The only way I could bring mass timber into the UK was to integrate it with structural steelwork, because then the disbelievers were still comfortable with the fact they had some form of structural ductility of steelwork combined with mass timber. If we go down the route of being purists, then we are being cost prohibitive, and therefore we'll never get VDC into the landscape of the future.
Very interesting thoughts. I was just smiling when you finished your first answer, because I know the answer. I know the questions that Julia had prepared, and you kind of answered them all.
Sorry.
In one shot.
I'll stop. I'll show.
You stretched from your first encounters till what happens in 10 years from now, which is great. I mean, why not?
Sorry, I've been in this industry.
It leaves a lot of. It still leaves a lot of room for
huge.
Luckily, we have 7 panelists. So, Rana, why don't you want to tell us about your first encounter with digitalization?
Yeah, I mean, I just remember. I mean, now I'm working internationally with a lot of partners all around the globe, and when I'm now in my 25th year of professional experience, and 12 of them I spent in Germany in conventional construction business. And I remember my last job at a big contractor that was a bioethanol factory in Belgium, where I happened to do some work. And back then in 2008, we just carried around all the stuff in a physical way in our cars to the construction site, and we needed to go back and forth. It was quite a journey from Eastern Germany to Belgium, just to bring information across, because even landlines didn't do it, and mobile phones and such. So it was my last memory that I have in terms of international collaboration. And then 4 years later, I went to Canada for doing some work there for CREE, and suddenly I found myself completely cut off the rest of the company. But I had my computer, and that was all I needed. I had Wi-Fi, I had my computer, and I had a desk that was like 50 centimeters by 90 centimeters, so that my computer could fit on it, and I could do all the work there because of the way we already used to collaborate. So even back then, we used shared screens. We transferred data. We held online meetings. Otherwise, we couldn't have done the job. So maybe that was the first encounter with communicating using digital tools in a big way. And also the design works, there was some Austrian architects involved, there was some Canadians involved, and it worked well. And later on in Singapore, I remember that one online session that we had where a Canadian structural engineer was involved, a timber installer from Taiwan, and some guys from Italy and some from Austria, and we needed to find a time slot during the day, and that was the big challenge. The digital environment was not the challenge. The challenge was like the globe and the time zones, right? That was, but we made it. I mean, then, and now we closed our first licensing contract with our American partner without even having met them ever in person. And this is, on the one hand side, very promising development to my understanding. On the other hand side, from a personal view, obviously a bit sad, because I really would like to meet those guys in person, and we definitely will. I mean, so was my take on spanning from then to now, at least.
Thank you, Rana. Thank you. Yeah, I remember that one meeting, and I think you were the one with the worst time zones, standing up at 4 a.m. or something for the meeting.
As usual. No, just kidding.
Sebastian and Marcus, how does digitalization in design and construction affect your particular work right now?
Yeah, well, what I'm very interested in this topic is that we still, you know, from a design perspective, you know, design is very haptic, and we still make models by hand, but we use a lot of digital tools. And what I think is really interesting and valid is to span the full media of, you know, going from the analog to the digital and back and forth, you know, because you do nicely models by hand and you scan it in, or you 3D print something, or you have a parametric model where you just, you know, you do some tests and you print it out and these kind of things. So I think it's the balance of the two worlds, I would say. And, you know, in a day-to-day practice, we're using a lot of analytical tools. You know, we heard already about BIM. And what we particularly like to do is, you know, have parametric design models, either in Rhino with Grasshopper or in Dynamo in Revit. And also use analytical tools like LCA, lifecycle analysis, you know, which is directly linked to your BIM model. And, you know, we heard from Nick or from Bernhard, you know, it's all about hybrids. So, you know, the building parts are becoming more and more complex, kind of like these high performance elements, you know, if you have concrete and timber in the game. So you're always weighing how much timber do I have in the game? How's the production process going? So these analytical tools help a lot. And then also it helps to keep cost and schedule under control, you know, what Nick mentioned with the 6, 7, and some people even call it the 7D, you know, if you say the sustainability. I think that's, you know, a big topic, you know, however you measure that, whether that's CO2, how you would say, a bill you need to pay for, carbon credits and these kind of things. And yeah, you know, everybody's using the normal collaborative tools. So that's a little insight into our work. And then, you know, we can talk probably a little bit later into how we are bringing the data from our design work then into the factory. I think these questions are coming a little bit later.
Thank you, Sebastian. Marcus, how does digitalization affect your particular work right now?
Well, I think digitalization is something that affects all of us every day, every hour, in many, many different areas. Bernhard mentioned structural engineering. We heard about BIM models, but in my eyes, it's a lot more. For me, the power and the big potential of digitalization is to link different pools of information together and to synchronize them. That makes it so powerful. I can remember quite well the first time when I did my first CAD model as a carpenter. I used to do this by hand with a little pencil and paper and tons of rubber to reduce all and make my failures well again. So and the next time I used a CAD software, it was SEMA, a carpentry software. It was just a click and all was good. Yeah, and it was really extremely important to understand your craftsmanship to make all these notches, and you need to have a very good understanding of geometries and all that. And that was so much easier and so much smoother using 3D models and a digital model for your work. And the next step, of course, was that you do not only have a single piece drawing, an individual drawing, but also a list of the timber. You could extract further information like weights, transport lists, and all that. So that really blew me away that time. And I think it is about that you can do such a lot of things with one integrated model. We heard it already. You can organize so many other steps and processes. But at the same time, it is also the big problem I see in that world, because this synchronization, these interfaces between all these digital islands, I call them, sometimes lead to a lot of problems. we see a lot of these Hollywood BIM models. I read that expression. I like it because it's so colorful. It's so great. You see everything. But if you dive into the details, you sometimes see that this is not really worked out well. Yeah, it's the diameter of bolts. It's the definition of materials. It's this and that. And in principle, you see what you get, but it's not usable 100%, at least not usable for all the different processes after. And I think that's one of the let's say problematic fields of digitalization or using digital data. And the other one clearly is also the operators. We still feed these systems, these islands, by human operators, and not everybody does the work 100%. And this sometimes also leads to let's say problems in that area. But there's no doubt digitalization is the only way to survive. I think in 10 years' time or something like that, if you do not get used to it, you will not survive in this world anymore. Also not in the building industry. And what we heard already today as well, it cannot be a revolution. It's an evolution. Yeah, it takes time. You need to go this step by step, because pulling the plug overnight, that doesn't work. Yeah, in the real life. And I think in the construction industry, this takes particularly long to maybe not pull the plug, but to go these steps of evolution.
Very true.
I'd like to pick up on one point. Sorry, Rana, to cut across you. What Marcus just said about people in different places working in silos, and there isn't something missing to join all this effort. And we are now participating as CREE in this research project, which is sponsored by European Union, and we've got partners from Finland, Luxembourg, Italy, and Netherlands. And even this morning we had a discussion, and there's already a big discussion and problem that each of those partners is working in different. They've got their own common data environments, and we are trying to find a way how all this information can be fed into one place, into one platform where everybody can have access and share that information. And this is already a huge problem. And we've got still 1.5 years to run in that project, and I hope we'll find a solution. But it's exactly getting people to dealing and sharing that information on some sort of common data environment.
I think that's important to take it as an evolution. Of course, there are a lot of problems ahead, but at least we are trying to solve them. And we have to start from somewhere. And I think it's very important that everybody integrates most of the projects in these or at least trying to working in a new process, and to really carrying directly all information into one model, and not like handing over these information to one and the others. And what you're saying, Markus, is of course there are errors being made, but much less than were made before, because now you can detect a lot of them. And I mean, when you look at the classical planning process, where we as an architect, we draw the first plan, and then later on the structural engineer was drawing, and then the MEP engineer was drawing, and then the company at the end of the day was drawing the old plan, the new plans, and our task, all of the planners, was to searching the mistakes being made in the plans, and that's over. And that's important. I mean, we are so much more efficient in this new technology than we used to be. And I think we can invest more time than in the quality of the buildings, and not losing so much time in complex planning or in complex information process.
This is where I see one of those biggest challenges, as you say, during the planning process. I think we are not doing too badly. We've got tools and we've got software to design various 3D models, carry out various simulations. But then the bottleneck is when this information being transferred to the construction site. The drawings are still printed in 2D, given to engineers on site who have to open those drawings and install something, you know, missing all the 3D important details. This is where I think the BIM and the digitalization is missing a little bit if you compare it to, I don't know, automotive industry.
Yeah, but this is why we are talking together. I mean,
trying to find a solution.
The timber industry or the timber construction industry is the only part of the construction world where this works.
Well, I would say
maybe
it's a
steel.
twofold. Go ahead,
well. Okay, sorry. Maybe Nick would say steel also lends itself towards that. But I would like to ask a question to Marcus related to that, because Marcus, I think you are the closest to the construction, means to the end phase of what we design, right? Because you run a company that needs to cut and needs to machine the components that make the structure or makes the walls, right? And you, in order to do so, you rely on 3D data, because this is what feed your machines and what cut and create those building components. What do you think if we are all dreaming of a world where the architect does a nice design and that all kind of miraculously transfers through the digital twin into your machine, and then the machine spits out the end product? What do you think? How close are we on a scale from 1 to 10 to that vision, from your experience as the one who is more who sits more on the end of this process? Or how do you experience it right now?
I mean, first of all, I think also others have the experience, but you might be right. We are the ones that really need to perform in the end. We need to bring millimeter accurate elements to site, and they need to fit. And there shouldn't be any further question anymore before producing something. And this makes maybe a little bit the difference to the rest of you, or a part of you, because we really have to feed a CNC machine with the exact data, and that's where maybe the devil lies. I don't want to be misunderstood. Especially because Patrick mentioned that. I think it is clearly much better, and I try to express this. But still, there are some steps to go in some areas to come to that dream that you just mentioned, roughly, Rana. We get the model from the architect, feed the machine, and let's go. Yeah. How far we are still away from that, I think it's still a bit. It's of course depending on the structure. It's depending of the model we receive. But at the moment, I think it's impossible to get something from the architect that can be directly transferred to a machine. But we are getting closer to that. Mm-hmm. And I think this is very important to mention as well. It strongly depends on what has happened before. So how far a company has been, a specialist has been involved in that process when the architect issues the model. And I think, as Nick mentioned, it's a very positive trend worldwide that we have PCSA phases coming more and more a daily thing in the construction industry. We have the same in Australia. It's called ECI or ESI, early contractor, early supplier involvement. That's a great idea. And our experience is the earlier we step in, the better the outcome, the smoother the processes are, and also the better the models are, because we can highlight already in a very early phase of the modeling during the architectural treatment of the model. Let's say, look, we have to do it this, and this is the dimension of the glue lamp or the panels and all that. So I think that's where the secrets are. Yeah, I would say we are at about 5 to 6 of 10.
I think what Marcus is saying, and working at Katerra, that was a general contractor that had its own integrated supply chain, but it went beyond that. It had an integrated architecture and engineering company as well, which were their own business units, so they had to stand on their own 2 feet. But when there was a company project with your own architect, your own engineer, your own supply chain, that works, so long as the business units within the vertically integrated organization have the opportunity to sustain itself. For example, the Katerra Mass Timber business unit has to stand on its own 2 feet, as well as building for Katerra. So because a vertically integrated business, truly vertically integrated business, that is the landowner as well, that acquires the land, how do you keep that factory going? You know, the construction industry works in a project environment, and we have lags, slippages, we have feast and famine in our organizations. How do you balance your resources? Well, the clever way to balance the resources is to make each unit, which is integrated, self-sustaining, that can trade with the outside world. That has to be that level of versatility. But that is to be vertically integrated. And I've seen great models. I see the Vastint model across Europe being truly vertically integrated. But then can the factory cope with its own demand without going too big? And then what when there's no more projects? You know, this is a clever way of thinking, is this? And of course, being vertically integrated, we remove cost on cost on cost, profit on profit. And this is how we actually make the whole journey much, much more effective. It can work. It can work.
Well, you know, I would say that it's not just about the translation of data, you know, from the BIM model into CAD/CAM processes, but we also need to have a better understanding, particularly in the early trades, you know, on the design and architect side, in relation to DFMA, design for manufacturing and assembly, you know, because if you, for example, you have a robotic facility and you have lots of robots producing wall panels, they can't handle vapor barriers on sheets. You know, you need to have a vapor barrier made in a different way as a board panel, or you know, so that the robot can handle the board. And it's also about what you can put on a truck. So there's, you know, all these new technologies and pre-assembly. So there's a big shift in how you design, how the details are made, what is made in the factory, what is assembled on site. And so I think we need to have way more training for our young colleagues, you know, in all the trades, in architecture and in engineering, to adapt to these new processes.
And you also brought up another good point, like DFMA. Everybody speaks about that, but that only really works if you know who is going to manufacture it, right? If exactly. You don't, everybody does it slightly different. So it's just a nice word in design that you can try to account for and be respective of the potential suppliers. But at the end of the day, if you don't know, you know, company X is going to do it, like it's tricky. And that's why I think those models, like when we talk about that evolution, it's really going to be the teams where the design as well as the supply like is one, like, because then you can really start doing that. Other than that, it's just extremely difficult. And one step in the other situation where you're not integrated is like you can try to say, okay, when we go up for tender, we provide a model that is, you know, with a specialist designer that is designed with the, you know, with the DFMA intent. Again, we don't know exactly who it is, but it has an appropriate resolution and level of detail and organization of the structure. And then you can spit out like a bill of material at the tender versus just, you know, sending out PDFs and everybody goes through with the markers and, you know, makes mistakes on the quantity takeoffs. But if you give that model out and with an Excel file, for example, that has the members, again, just because you have an Excel doesn't mean that the data is right, but at least everybody is bidding on the exact same baseline. So you're removing the variability in the quantity takeoffs, right? With the understanding the Excel is still, it's not based on application model, so there's still going to be errors if you compare it to the final build, but at least you're leveling the playing field and you're taking out that variability of the quantity takeoffs with the, you know, with the marker. And I think that is one step towards that evolution that we all can do. Like we can, you know, hopefully get to work in those closed environments, like down the supply chain. And if we're not, there's still steps that we can do to try to help others in the team understand and to make it a little easier for the supply chain down the road, also on the bidding, right? By leveling the playing field a little bit.
It's quite interesting. I mean, we are working on 2 projects at the moment where we intend then to print out the project later on. Markus, you're bidding on one of them. I mean, let's try it. I mean, we have at least to try it, and it only works. And I think that's very important on an integrated process where the companies enters as soon as possible, because I mean, later on, these machines have to build it, and you have to know which size of panels and which connections and whatever. And I'm pretty optimistic that this can already work. Maybe at the 12th anniversary of CREE, we discuss that again.
Thank you.
You're welcome.
Thank you all. It's a very interesting discussion, and we now discussed a lot about how digitalization currently happens in the construction sector. A couple of examples what goes very well, or some things that do not go very well right now. We do not have that much time left, so my last question, or that's rather a task to you, is if you could please give me one big idea that you have about the future when it comes to digitalization in construction industry. And whoever wants to go first.
I would start maybe, because I would hope that this idea of this digital storage of ideas lasts longer than the construction process, so that we as the automotive industry are then able to replace spare parts, to continue working on these kinds of buildings, to create flexible buildings where you can maybe change the usage later on. I mean, that would help us even more to save material and to save the planet.
Thank you.
For me, it would be something. Oh, sorry, Nick.
No, okay. I was going to say, I think the drive for offsite and lightweight materials is a natural evolution towards BIM, regardless, because the automotive industry operates in a 3D world. You don't see 2D drawings in the car world. Everything is in 3D automation. I think offsite is how we will naturally evolve into a BIM environment. And we've seen that more and more across the world for offsite technologies. And I think we're all very fortunate who's in the space of mass timber is evolving into that space. And I think that's how we get there. It's maybe mandating our clients and our governments to mandate BIM, full stop, for all projects. That's the way we will enforce this.
To follow on what Nick was just saying, for me, this bottleneck that I mentioned before, that this transition from the planning design stage to construction, bringing any new digital tools like virtual reality, augmented reality, something that enables engineers on site to visualize how the building should be built, how the services should be installed. That would be very helpful. So anything we're participating ourselves in our company, looking at different sort of options with HoloLenses and VR goggles, and anything to help engineers on site to visualize the final product would be very beneficial.
Yeah, okay, then I continue taking up the word from Wojciech regarding some of these visualization opportunities. We are just working on doing virtual tours that are augmented by technical information. So this is where we are already at. So that means people don't have to visit our buildings anymore. They will follow through them on their screens, and by doing so, by having this live experience, they also get background information on the structural design, on details. They all come with this augmented reality. So this is just the beginning of something that will lead into a situation, let's say in 10 years from now, where to do design and construction, literally no one needs to meet physically anymore. Even on the construction side, we try to reduce the number of workers because they could potentially meet there. And this is very bad. So then we also remove the workers from the prefabrication side because there are a lot of things that can be done by robots, right? So there is a potential that we don't meet each other anymore, only on the screens. And that's why my big vision is still meeting up with one another in a physical way, but not destroying our environment. And this is something that might go beyond digitalization. And since I feel a bit like the representative of the founder of CREE, Hubert Romberg here, I can make a bold wish and dream beyond limits. I think in 10 years from now, I'm going to travel by myself, but through some kind of digital or even quantum physics tool that brings me physically to another place to meet with you guys, maybe at the same time, always being me, like many of myself, something like that. Yeah, at least at one place where I don't have to enter a plane and or some other means of transportation. I just go there like I go there with a picture or a text now via WhatsApp. So that's my vision for 10 years, maybe even 5.
Thank you, Rana. Thank you. Sebastian, what would be your big idea?
Yeah, I would like to pick up the thought that Patrick had, because that strikes me particularly too, is that, we not think about digitalization or BIM for the construction and assembly process, but also extended towards the life cycle of the building. So that we have, it's first about the life cycle of the material. And, that's particularly cool and with the BIM model, because we know exactly what's in there and how, what carbon footprint we have in the building and when it was serviced and built and what's the content and so forth. So we can, as we build the building, and it's all prefab and offsite construction, but we can very nicely inverse this process as well. And so therefore we can build a way more efficient and cheaper and make a better use of our resources, whether that's concrete or steel or any other material, aluminum. And so to have a carbon credit for every project, which is available to everybody, a lot of people are talking about urban mining. So that's a little bit involved into this as well. And so then with this, we can get, again, the balance right between what we need as people, for proper living environment, but also to fulfill the needs of the planet and also make a profit, because that's what we do. We need to make a living. So just to put people, planet, profit into one line. That's what I would say.
Thank you. Thank you, Sebastian. Marcus, what would be your big idea for the future, or that you have about the future?
Honestly, I do not have that big idea, and I doubt a little bit that it exists really. I think it's a summary of many little ideas that create together a big one. And I think many of these components or many of these ingredients of a big idea we heard already today. And I don't want to repeat them again, but maybe we should also think about to make building with timber much easier than it is at the moment, because it's really hard work sometimes. We have to reinvent the wheel again and again. We have to start from scratch to do a timber building. And this is, of course, based on the situation that we have hundreds of different ETAs, European technical approvals. Every product is different. Every manufacturer has its own product. We have hundreds and thousands of different connectors. And of course, this makes it, especially for our colleagues, Sebastian and Patrick, very difficult to choose this or that idea. What is the right idea? What is the right solution for that? So that's a part of my big idea, to make it simply easier to build with timber, to make it more accessible for everyone, to make it more standardized, to ideally click on an online tool. I want that building, that size, and then I can send it to the CNC, and it will be delivered automatically. Maybe not by robots like Rana would like to have that, but by human beings in a truck to site, yeah, and then erected by robots. That
occupied.
Is maybe my vision. Make life easier for all of us, because that's sometimes a bit exhausting still. Yeah.
Thank you.
Very well put.
Bernhard, what would be your big idea?
It's not a big idea or vision. It's more kind of a like a wish that we all gonna find project teams and clients and suppliers that we can carry forward from like as a team from project to project. Because if we can start doing that, we can really start showing the benefit of all that we talked about today. Like, and once we do that, and then others will understand that there really is a benefit in doing so, and others will jump on that process as well. So it's more like a wish than a vision.
Thank you.
Very good point. Very good point.
Thank you for that, and perfect closing words for today. We have unfortunately come to an end. Thank you very much. There have been some questions from the audience. We'll address them afterwards via email. Nick, Patrick, Sebastian, Bernhard, Markus, Wojciech, and Rainer, thank you all for your time and an extremely interesting discussion. Thank you for your input. And yeah, part 2 is calling.